Stanley Black & Decker provides tools and services around the globe to help turn great ideas into reality and to help us shape the world we live in. We proudly support programming that inspires invention, innovation, and hard work. Together with Make48, we're providing men and women the tools and resources to build a better world. Stanley Black & Decker, for those who make the world.
ACE is made up of thousands of entrepreneurs with a passion for supporting innovation. With more than 5,000 locally owned stores worldwide, we help supply resources and tools for neighborhood makers and inventors.
ACE is the place with the helpful hardware, folks.
For more than 30 years, QVC has been dedicated to finding and supporting innovators, inventors, and entrepreneurs. Our shopping experiences help entrepreneurs bring their products to life and share compelling stories of grit, determination, and creativity.
On the last Make48, the teams presented their inventions to the judges.
360 degrees, perfectly illuminated.
And the top 3 teams were announced.
So of course, as you know, we're going to give away 3 prizes to the top 3 winners.
Stay tuned as the journey to the marketplace continues. Welcome to Make48. Everyone's got a big idea.
Competition's come to an end. We now have 3 products that we can work with and take to market. The prize they get is a license agreement, and it's 5% of wholesale. The inventors themselves get to retain the patents on the product, and that's really important because they get to have that as an asset that they can sell one day, or it can be acquired by a bigger company. The strategy of this is going to be really important. We're going to use a whole bunch of different companies, a lot of experts. We have to get opinions from several different people to help this product advance all the way through. Licensing is a very common procedure that happens in the invention industry. Inventors and creators have the idea but just don't have the resources to get it all the way to the end.
So we're in New York City and we're here about to go into S&S Design and meet Nisha and her team and talk about that drink slinger.
My name is Nisha Sani. I'm the founder and CEO of S&S Design. We're a global industrial design firm. So, okay, you have a bulb idea, bulbs like
We got it right here. It's a great idea, I think.
And people think like, oh, this is it, no one has it, and this is going to make me millionaire. But that's not the reality.
Okay.
So what I tell my clients, inventor clients or startups or starting businesses, is it solving any big issue? Can it be mass marketed? Can it be manufactured cost effectively? We have to also think about patenting. Do you want to sell it in US or global market? Because cost keeps adding up as you build up. So we're not just designing a product, we're talking about the whole business.
So the first step is obviously research. So what do? You go to Google?
The simplest, the cost-effective way, do a lot of Google search. Yahoo search, Bing search, image search, as much as they can do. So their issue was basically you are on the beach or you're in the stadium or you're doing barbecue like this, right? And you have to carry 10 cans for your friends.
Multiple cans.
Multiple cans.
Okay.
I looked at the product idea. I think it was a great idea to start for the problem that they were trying to solve.
So we passed on the research so we can make this as a viable product.
Right.
So some of the key points about any product on the market is the ability to manufacture it at an affordable cost.
Right.
The next step is the manufacturable scalability of this product. So obviously there's some issues with the 3D printed prototype. You know, they only had 48 hours, so they did a great job. So
yes, absolutely.
Let's walk through some of the problems you see.
The slap band, it's off-the-shelf product, the
Right.
piece, right? And what they did is they have to cut open and put the metal strip through the plastic. So it's a lot of surgery that they did. You know, we don't want to do that from final manufacturing.
You want to purchase this product right off the
As
shelf as it is. The original prototype, they had to remove and tear apart the existing koozie, the spring-loaded koozie, and then try to reassemble it.
Because that increases your manufacturing cost, your assembly cost, your labor cost, it just all adds up. So we need to eliminate all that and use the existing part as it is with minimal cost and assembly required for it. So the first thing what we did is put 2 holes in the slab pad where the metal bands are and tried to use it as it is on the holder, which worked great.
So that solves the problem of trying to cut it apart and reassemble and stuff like that.
Right. So we were thinking about how do we mass produce this, because this is no way we can do a solid handle. The handle was very heavy on material, so we had to do certain things to reduce the cost of manufacturing the plastic and the mold cost. So we tried to reduce the material and still make it stronger. So we provided rib slick on the sides just to try it out, and we did a quick 3D printing just to see how much we can reduce material and save on cost. And with this, we realized that, you know what, there can be hygiene issues.
So this is a problem that you're still working on to get through that, to clean that up. So we see it's an evolving process.
Correct. The inventor had a holder, separate holder to hold 5 in the holder, which is unnecessary. It's just adding extra cost, unnecessary extra cost.
Sure.
Plus you have additional part that you have to keep, not to lose it. So we remove that, and then we change the interlocking details so that it works perfectly without the holder in your hand, in 2 hands.
Keep it simple.
Mm-hmm. Keep it very simple. Exactly.
Ultimately, the best way to invent is to have a mastermind team, designers and marketers and packaging, and have a team to help you create that product in the best possible way.
Bob sits down with Joe from SNS Design to learn about digital tools that simulate injection molding.
So you're always concerned about the manufacturability of this plastic, and those concerns is how is the mold made, correct?
Yes.
So is there a way for us to not have to spend all those expensive costs on a mold and trial it in 3D world?
The first iteration is always the lowest cost in tooling. They may not look the best apart, and then it comes, we'll have to compromise. Okay, we're going back and forth. This doesn't look good. I have too many ribs on a part. Let's get rid of them. Let's do it some different way. So we end up to be a balance between aesthetic and manufacturability.
Right.
So good design.
With today's technology, they've created these programs that can simulate plastic mold injection.
So in between times, I always run simulations. Like, for example, gating in this corner or gating in that corner.
So this particular program is to run a simulation of a plastic mold manufactured part, and then it points out some troubled areas.
It tells me that's the red is like, okay, it's not going to feel, it's going to be short shot or something.
Mm-hmm. So this is definitely a very crucial part of the process. So that way nobody will go out and spend $100,000, $10,000 or any amount of money. This will be able to tell us if it'll work.
Yes.
The old days, the tool and die maker that made the mold would know if that's an undercut or if it's your injection spot is too far away, it needs to be center. When it cools off, will it curl? So it was a lot of trial and error. So it's amazing to hear all this, just something so simple, and there's a lot of detail and thought not only in that, but the design element, like you said, aesthetics and the manufacturability. So the gate's important, the flow rate, you called it short shot, meaning it didn't fill the whole cavity and so forth. So there's a lot to think about. So that's why we need you.
The wedgie poses some unique design and manufacturing problems. Courtney meets Team DAD at Make48 Design and Invent.
We're here in Austin, Texas at Make48 Design to go over the wedgie, and they redesigned it into a more manufacturable product.
When we look at the original photographs that came to us, the first thing that we had to do was talk to all the different stakeholders. How would a customer use this? What are the different ways that we could conceivably build this product? What are the features that we have to have? Or what are the features that would be nice to have? Or what are the features that maybe we'll table for now? Price point that's accessible to the mass market, that kind of limited it, but we didn't want to give up on quality. We don't want to give up on user interactability. So that's why Tim put and the team from Make48 put considerable effort into figuring out how can you actually build this thing, but in a cost-effective, manufacturable solution, we're not looking at, a few units. We're looking at potentially tens, if not hundreds of thousands of units worldwide.
The wedgie overall is a simple product. All there is padding, a little bit of fabric, and some hinges here and there. And so for the redesign portion of it, it's not going to be a big redesign like some products.
The price point that we came to that we had to make this product for was roughly around $13 to $15.
Yeah, and that's manufacturing cost.
The problem with the price point on this particular product is that there are very large areas of material on it. The foam and the outer covering are large pieces of fabric and large pieces of foam, and they tend to, the cost mounts up pretty quickly. We did end up removing some of the foam in areas like this little pad down here, just to reduce the cost on that. But what we did add was a self-inflating system, so it acts a little bit like a camping mattress.
I mean, we never would have even thought about that, or even thought that that was something that would be fit into the price point. So it's really exciting to hear that. I think that's a great addition.
We knew when we were making during the 48 hours, the prototype, we were grabbing what we could. But that's why we're really happy with the fact that they, have the fabric experts and the material experts to know what to make it out of. So really, I think they added a lot.
It really comes down to the price of a few valves, and essentially the principles upon which an existing camping mattress work is essentially that it has some foam inside it which expands and sucks air inside. So we already had the foam there. We thought we'd just add the air.
Taking it from just foam pads, adding in the idea of the inflatable pads to make it less expensive to manufacture, more comfortable. That was an interesting and innovative approach to solving that problem.
So Tim, a question we had was around the awning and holding it in place. One concern was you're on the beach and the wind picks up. Is that snap into place and keep it from flopping around?
The poles that actually hold the awning up actually clip into little slots here in the end. Oh, wow. It actually pops in there. It's got a little kind of mushroom head on that pin, so that it wouldn't just easily pull out again without you working on that.
Well, the interesting thing about this is that although it looks relatively simple in its final design form, there's quite a few different elements in it, quite a few different types of design techniques. You think about all the different materials. In terms of, you've got the inflatable pieces, metal rods, plastic injection molded insertion pieces, and all of that. All of those are done in a way that is essentially intended for mass manufacture at volume, which is really what's helping to kind of pull that price point down, even just bit by bit. And it helps a lot for the eventual business, which is the most important element of getting this product out to the market.
In some ways, it validated our design because I felt like they didn't have to stray far from it to make the next level prototype. A lot of the structures were the same. They added in new features that were valuable, like the cushioning.
To me, what differentiates it from a beach chair, people are saying, well, why am I going to buy this over a beach chair, is the fact that it lounges too.
That's what makes this product so amazing, is just all the varieties of the different configurations that we can get by just folding different panels in different ways.
Rich takes Joe from Team Believe to a local makerspace to discuss prototyping options for the 360 uplight.
A makerspace is it's a space where they get to go use tools, have access to knowledge, tools that most people wouldn't have in their garage, 3D printers, laser cutters, including all your hand tools and wrenches and that sort of thing. So we're going to Hammerspace, that's a makerspace in Kansas City, and we're going to 3D print the 360 uplight.
All right, gentlemen, this is Hammerspace Workshop. We're a makerspace, which we like to think of a makerspace as being sort of like a gymnasium for folks who like to build stuff. So instead of joining a gym so that you can have access to millions of dollars worth of Nautilus equipment and an Olympic-sized swimming pool, you come to the local makerspace so that you have access to walls full of tools, huge manufacturing equipment like CNC machines, laser cutters, and 3D printers.
I would love to belong to something like this. Bring your dream in here and just make it happen. Pretty much like a playground for an inventor.
So a guy could bring in on a thumb drive a drawing he needs laser cut or CNC'd and
walk out, same day or next day with a professionally fabricated part for their creation, whatever it may be.
I like that you can just come in here with your concept and you can just make whatever.
This is the classroom space here at the workshop. This is where we teach things like drafting for 3D printers, or how to draw objects for a laser cutter, or sculpting, or other sorts of crafting.
What we needed for the 360 Uplight was a larger build platform for a 3D printer.
So here we have a couple of printers that are currently printing some parts for the 360 Lite. These are Oni Technology 3D printers, and these are made right here in Kansas City. Tom from Oni Technology developed these, and we manufacture them with his help here at the space.
And we're going to print the first versions of the 360 Uplight on those printers so that we can get a nice look and feel model, make sure it works really well before we move on to the more expensive ones.
Okay, Joe, you recognize this?
Yeah.
I think this prototype, I like to say the first ones always have to be ugly or you're not doing it right. I think it qualifies as ugly.
Well, I think beauty's in the eye of the beholder.
$48, it's not too bad. So
get to your proof of concept and then iterate.
Absolutely.
Right.
So speaking of iterate, we've come a long ways here through iterations of different 3D prints. This one, for instance, we did on our printers, which cannot print the whole thing. They can't print the full size because the build platform is just not big enough for your product. So what we did, we made it in pieces, which allows you to kind of prove the concept and take small pieces, short run, like this takes maybe a couple hours to print, and prove that that's actually going to work.
I like it. I like it.
Even though it's just part of it. We just take parts of it and print it. Then we can take those pieces and put them together, change them, figure out what works, what doesn't. And then when you're ready to make a longer print on a larger printer like Dave has, then we can do that and take the 20 to 30 hours it takes to print something like that.
Right.
And this came out beautifully. Take a look at that. Full size.
Dave, that's what's up. Wow.
Yeah, we were really pleased with how the part came out. You've got enough flexibility to get around a large potted plant or tree. And this should be a very similar consistency to what your finished commercial product will be when it gets done.
Can't wait to report to my sisters what's going on here. Team Believe, we're a really close family, and they're so excited about me coming down here to do this. And so yeah, I can't wait to tell them where it's at, how the 3D printing's going, how it's evolved. It's just a much better product now.
At Make48, when we built the first prototype, what you used there, you just found Christmas lights, right?
Yeah, we totally got them off the shelf.
Just
took them out of the stuff. And
right out of a store, off the rack,
Yeah.
just plain old
Had all
LED
these
Christmas
extra
lights.
lights on it. We had to tuck them up under there.
And that's a great way. Just use products off the shelf, hack together whatever you can.
Right.
Then after that, you want to start refining that process, and the process actually evolves into a product that you would see on a store shelf.
So let's say you're inventing a product like the 360 Lite that needs LEDs on it.
You could design a product, design those lights, exact spacing, exactly what you want with the right LEDs.
One of the things we did on a 360 Lite was we ordered some LED lights with a battery pack. You can custom manufacture exactly what you want for a part to go in your end product.
So you can search what you need made and find manufacturers from all over the world, a lot in China, that will make exactly what you want. They'll give you a quote. Quotes usually within days. They'll send drawings, and you can go back and forth with them and get exactly what you want made.
So the process goes, okay, I give them the exact measurements and all that, and then they would send me like a sample of it, right?
Right.
What would that cost me?
A lot of times they'll do free samples, but it's fairly inexpensive because they want the big deal. They want to do a container full.
Like say I came here and I need that information. Would you be able to help me get that?
Yeah, that's what the Makerspace really excels at. Now here in-house, what we'll do is we'll take you downstairs to the store and get you set up with LEDs and other components that you might need that we carry right here in-house, and then help you develop a prototype printed circuit board based on the breadboard that you develop here in our electronics lab. So we could take that down to the laser shop and fabricate a copper-clad board that you could lay out and make sure that the design that you're sending off to your manufacturer is going to function before you commit to several thousand units.
Right.
Bob, along with James from Team Mount Hoodlums, goes to a nonprofit makerspace at a public library to get help with the first prototype of the Drink Slinger.
My name's Nick Wardbop. I'm one of the Makerspace facilitators here at the Johnson County Library Makerspace. And we teach patrons, we teach inventors, we teach hobbyists, nonprofits, anybody who comes into the library how to use the equipment. We have 3D printers, we have sewing machine, CNC machine, laser cutters, we have digital media production and a sound booth, all free. patrons of the library. You don't need to be a card holder. You don't need to have a library card.
So is there more maker spaces like this in other libraries that people can reach out to?
There are. Kansas City, Overland Park, Johnson County, we're super lucky to have this library. But if you reach out to your community, I'm sure there will be a private makerspace or a public library makerspace that's going to help you. If you are an entrepreneur, if you're an inventor, you're looking to get something printed.
I found that I use the tech shop a lot. I did all the classes there several years ago. I was working at a startup at the NASA Ames, and they paid for me to do all the classes, and it was wonderful.
Yeah.
And I've seen a lot of startups working in these spaces, and it's such an incubator for new ideas. It's fantastic. I wish my local library had this.
The new modern makerspace is kind of a new thing, but our grandparents had a set of tools in their shed or in their garage where they repaired or built furniture or things they needed around the house. High schools, colleges traditionally had woodworking and metalworking classes. As those have gone away, public libraries and other nonprofit and for-profit makerspaces have kind of filled that void.
So if I bring in a CAD drawing that's already done, you'll 3D print it for me? Is there any charge for that 3D print?
Well, you will 3D print it for yourself. We'll help you though.
So it's an educational process.
Exactly.
You learn, this is like such a gap in people's knowledge of how to use all this equipment to actually make real products. It's actually really encouraging to see public libraries starting to do this. My library is a nice big library, but they just got, right now, just 2 3D printers hidden in a little closet, and it's locked up. You don't have access to it. So I'd like to see more of that.
So the first version.
That's our first love right there from the contest. We had these, and we were really worried about this being too thin and breaking.
Absolutely. So the whole deal with any project or product is the improvement, but more about manufacturing process.
So we were able to take it pretty far at the event, but we realized that there's just so much compressed, there's so little time that we couldn't work out all the kinks, and there were still questions about how to make it manufacturable. I can see how they've now taken it to the next step.
And you can totally tell this was designed for 3D printing during the competition. Now you're moving on to manufacturing.
Absolutely.
Because I can see now how you design this.
Undercuts are important.
So you can pull the mold out.
Exactly.
And you don't have solid plastic like here, so you're not going to have issues with cooling at different.
Right.
This was printed here at the Makerspace, and you can tell, still has the supports on it.
So let's explain that. So the build support, it looks like you printed it this direction.
Correct.
So if you take it without the build support, you'll see they've added little towers, and those, I assume, just break off?
Yeah, it's like scaffolding. So you're working from your first layer up, and if something's overhanging, you have to have something underneath that when that hot filament's coming out for it to land on. Something as simple as the drink slinger touches on so many different foundational skills: geometry, physics, math, industrial design, and it's awesome that people can go and get those first iterations, those first prototypes here at the library, which is why our door count is somewhere between 150 and 300 per day. There's people coming in with ideas like that and executing. So we've got the Ultimaker 2 going right now, and it's printing, you can tell, in this orientation. And the reason it's printing in this orientation is if we printed it like this, we'd be putting support structure all the way in this cavity.
Oh yeah.
So waste material, and you have to cut it all out.
Exactly, and it'd be totally fine all the way up here and all the way up here without support, but once it gets to this, there's nothing underneath it to support it. So that scaffolding, that support material, which eventually will just pull out, you would have to do it that way.
I can see here it says it's got 3 more hours to go.
That's right.
3 hours?
You guys got 3 hours to hang out?
Yeah, we do,
All right.
especially in this place.
Cool.
Yeah.
You probably have resources like this in your community. You have to reach out, find the public library that has a makerspace. There are a lot of small nonprofit or for-profit makerspaces where you might be able to prototype your idea.
On the next Make48, the prototypes get further refined.
Good job.
Nice job, Chris. Appreciate it.
And the inventors get hands-on with their products.
It looks like a finished product. So some you'd get out of injection mold.
Then we check on the progress of the Whiz Bang product from Season 1. Everyone's got a big idea.
Stanley Black & Decker provides tools and services around the globe to help turn great ideas into reality and to help us shape the world we live in. We proudly support programming that inspires invention, innovation, and hard work. Together with Make48, we're providing men and women the tools and resources to build a better world. Stanley Black & Decker, for those who make the world.
ACE is made up of thousands of entrepreneurs with a passion for supporting innovation. With more than 5,000 locally owned stores worldwide, we help supply resources and tools for neighborhood makers and inventors.
ACE is the place with the helpful hardware, folks.
For more than 30 years, QVC has been dedicated to finding and supporting innovators, inventors, and entrepreneurs. Our shopping experiences help entrepreneurs bring their products to life and share compelling stories of grit, determination, and creativity.
To learn more about the invention process and to get to know the teams, visit Make48.com.